Okay, so last section we're going to take a look at this week is 9.4. We'll spend the next couple days, 3 days, looking at this section. And this is on what we call conic sections. So conic sections are basically, you imagine taking a cone and slicing it different ways, and then looking at the shape you get when you slice it. That's what a conic section is. So I think this picture shows the different conic sections pretty well. If you take a cone and you slice it straight across, you get a circle. If you take a cone and you slice it at an angle of making sure you go through the sides of the cone, you get an ellipse shape. If you slice a cone but you come out through the bottom when you slice it, and then look at the shape you get after cutting that part off, you'd have a parabola shape. And if you put two cones kind of back to back with the point of the cones together, and you slice it straight down, and then look at the side, you would end up with a hyperbola shape. Right, so those are the 4 different conic sections you can get when you slice a cone. We'll spend 1 day looking at each of them. And today, we're going to focus just on the parabola. And the parabola is a little different than the other 2. So the other 2 we're going to study. We're not going to spend a lot of time looking at circles, because a circle is really a special case of an ellipse. A circle is an ellipse where the length and the width are the same. That's all that a circle is. So we'll kind of look at circles and ellipses together. That'll be next time. And then hyperbolas will be the last one we do. Questions on those 4 different shapes? So for each shape, what we're going to do is we're going to start out with the definition. Okay. Let me give you the definition of a circle, even though we're not going to do that one today. That's the easiest one, I think, to visualize. And the way you would define a circle is you would say it's a collection of points equidistant from a given point. That's a circle. It's a collection of points that are all the same distance from a given point. That given point is called the center. Now, I'm going to do the same thing with a parabola, but the definition is a little bit more complicated than a circle. Right? So I tried to give you the circle first so you kind of understand the concept of what I'm going to do, and then we'll do it with something it's a little harder. So a parabola is a collection of points, and those points are in the plane. What that means is this is a 2D shape. A parabola is not a 3-dimensional shape. Something that's 3D and has a parabolic shape would be called a paraboloid. But this is a parabola. So a collection of points, 2-dimensionally in the plane. And these points are all equidistant from 2 things. Not just one thing, but they're all equidistant from 2 things. If you measure the distance from any point on the parabola to a special point called F, which stands for the focus, and then you measure the distance from that same point to a special line called the Directrix, those 2 measurements will come out exactly the same every time. So you pick a point on the parabola, measure the distance from that point to the focus, and then measure the distance from that point to what's called the Directrix. And it will always be the same. Right, I'm going to show you an example of that as an image that I can actually move things around on, and you'll be able to see hopefully what I'm talking about. So here's a picture of a parabola. This particular parabola opens down. B is a point that I can drag anywhere that I want along the parabola. As I move point B, I'm going to watch what happens to two measurements. The distance from A to B, I want to measure that, and the distance from B to C. I want to measure these two distances as I move it. Okay, so watch what happens. So these two numbers at the top are going to change. You click B, drag it, and notice what happens as I drag it. Distance from A to B and B to C always stays exactly the same, no matter where you put it. Put it anywhere you want. And that's what makes something a parabola. The distance from the point to what we call the focus, and the point to what we call this directrix. Those two distances are always the same. Any question on that idea? All right. So let's take a look. Get rid of that. Next thing was I was going to tell you what these two things are called. I already wrote them up here. So focus and directrix. And let's talk about a few other vocabulary words before we start looking at an example. Parabolas have what we call an axis or a line of symmetry. The line of symmetry for a parabola always goes through the focus, and it is perpendicular to the directrix. Look at this. Here's your focus, point A. Here's your directrix, up here. If you draw a line perpendicular to the directrix, so it makes a 90-degree angle, and it goes through the focus, that would be the line of symmetry for the parabola. Right? Straight down through the focus. That's called the line of symmetry, or axis of symmetry. Here's the same thing again. Here's the focus. Here would be what's called the directrix. Notice the parabola always bends away from the directrix. The parabola should never touch the directrix. It's an imaginary line that it bends away from. And the focus is an imaginary point inside the parabola that it wraps around. So the focus is always wrapped by the parabola. That's how it works. Here's your axis of symmetry. Perpendicular to the directrix, and it goes right through the focus. Now, this point has a special name. Anybody remember what we call, in this case, it's the highest point in the parabola. Sometimes it's also the lowest point. Yep.
Vertex.
It's the vertex. Another way to say it, based on this picture, is the vertex is where the line of symmetry crosses the parabola. Okay, so where the axis of symmetry intersects the parabola, that's called the vertex. A parabola only has one of them. When we talk about an ellipse and a hyperbola, we'll talk about vertices, a plural. But a parabola only has a single vertex. And there's one other distance that they sometimes talk about with a parabola. And let's say this is the focus, and that's this distance. It's the width of the parabola. But you can't always say the width is the same, because the further you go on the parabola, the wider it keeps getting. So this is the width of the parabola through the focus. And the name for that distance Bless you. They call that distance the lattice rectum. And we looked that up in another class, and it's Latin for something. I can't remember exactly what, but it basically means like distance to the sides. That's or width through the sides or something like that. But it's Latin. Line to the edges, line to the side. Can't remember. Another term for it you might also see is focal width. It's the width of the parabola through the focus. So if you see a problem in the homework that asks you to find like the lattice distance or the focal width, and that's part of like a multi-step thing, you can ignore the part that's asking you to do anything with lattice distance. Okay, we're not going to focus on it. I just wanted you to understand what it was. All right, but there are some questions in the homework that say find the focal width. You don't have to do that. Yeah, I think the questions ask you to do like 3 or 4 things, but you can skip that one thing. Questions on that? And parabolas, basically, there's 4 different cases. They can open up, down, left, or right. We're not going to be looking at like a parabola at an angle or anything like that. But those are the 4 different cases that you can have. Up, down, left, and right. We'll try to look at each one of them. So we're going to start by looking at an example where the parabola always has its vertex at the origin. Can you shift it from the origin? Yes. We're not going to shift it yet. So we're going to keep it at the origin. And the focus is going to be a positive number, comma 0. Now, think about that for a second. There's your vertex. If the focus is a positive number, comma 0, where would it be in relation to the vertex? Up, down, left, or right? Yeah?
Up.
That would be 0, comma A.
Wait, what was it?
Sarah?
Right.
To the right of it. So the focus would have to be somewhere over here. I don't know how far over, but some distance over. Now, if that's where the focus is, and I told you the parabola always wraps around the focus, which way does this parabola open? Chris?
To the left.
No, if it opens to the left, it wouldn't wrap around the focus.
To the right.
Yeah, it has to open to the right. All right, so how wide or whatever, how narrow it is, I don't know. But I'm just saying, in this situation, where your focus is a positive number, comma 0, something greater than 0, that's why I'm saying positive, and it's starting at the origin, and it has to wrap around it, it has to open to the right. Any questions why it can't open up, down, or left? All right, and the equation for a parabola opening to the right is that y squared equals 4ax. Now, how many different cases did I say there were for parabolas? Yeah?
4.
4. So there's going to be 4 variations on this formula. The variations are basically going to be, is this a positive 4 or a negative 4? That controls part of which way it's going to open. And then, what is the letter that's raised to the first power? And what's the letter that's raised to the second power? This is a positive number, and there's a letter x here. So the way I read this to myself is I say positive x. positive x. If you have a positive x, think about which direction the positive x-axis goes. Positive x goes to the right. So this graph opens to the right. If you have this, I would read this in my head as negative x. Negative x, think of which way the negative x-axis goes. To the left. It would open left. And then if you change this x to a y, you did something like this. Okay, I look at two things on this side. Positive y. That's how I would read that one. Positive number, letter y. Positive y, which way does the positive y-axis go? Sarah? Up. So this type of equation would open up. If I put a negative floor in front of it, I would read this as negative y. It's a negative with the y. Negative y, the negative y-axis is down. This graph would open down. Right, so we just look at this number and this letter. And then whatever letter you put on the right, put the letter you didn't use on the left and square it. And that's basically the four different equations. Okay, but we're going to go through each one of them one at a time, so we'll write some things down about them. But I just want you to kind of see the general pattern. Right, but let's start with this one. Notice that all these equations are written like this. You have to write it with the number 4. So this is the way it works. Okay. You always want to have a 4, another number which you may have to find, or maybe they'll give you, and then a letter. All right. The next thing is basically about graphing a parabola. And there's a few things you want to make sure you do when you're graphing. The first thing you want to graph is the focus, the vertex, and the directrix. Out of those three things, the vertex is the only thing that is an actual point on the parabola. The directrix is an imaginary line it bends away from, and the focus is an imaginary point it wraps around. They're not actually part of the parabola. So once you graph the vertex, which is a real point you're going to draw through, then you want to find two other points. So in general, if you can get your vertex and then get two other points, then you can make a pretty good sketch. Three points is about what we're looking for to draw a parabola. So here's your vertex. We'll get a point. We'll get another point. The 2 points might be in line with the focus. They might be above it. They might be below it. But as long as you get 3 of them, then you can do your sketch. Now, I mentioned that the equation is always written with a 4 and then an A. Well, I should tell you what A is. You know what? I'll do that when we do our first example. All right. So it says find an equation of the parabola where the vertex is at the origin and the focus is 3, 0. So this is the kind of problem where I'm giving you some facts about the parabola. And I want you to take those facts and turn them into an equation. So let's talk about what that A is. A is a distance. Right? It's something that you can measure. And A is the distance between the focus and the vertex. It's It's the distance between the focus and the vertex. I'll bring this picture back. I don't want to look at it. Because A is also something else. And I think if you look at the picture, you'll be able to see what else A is. So I said to you, A is the distance from the vertex, let's call that the letter I've been using, to the focus. This is A. Distance between the vertex and the focus. Does anybody see what other distance in this picture would also be A? Yeah?
The vertex to the directrix.
Yeah. The distance from, well, I just don't want it to look too confusing, but the distance from here to here is also A. So what would be the distance from the focus to the directrix? Yeah?
A squared.
So like if this was 5 and this was 5, it would be 25? 5 squared?
No, A plus A.
A plus A, which is? Yeah,
2A.
2A. So the distance between the focus and the directrix is 2A. We're not really interested in 2A. We're really interested in just A, but that's a true fact. So A is the distance between the focus and the vertex, or it's also the distance between the vertex and the directrix. You can think of it either way. So or the distance between the focus and directrix. So depending on what information they give you in a problem, it gives you a little flexibility how you figure out A. Right? You got a couple different things you could work with. All right, so let's see if we can get our equation. First, let's say we didn't even know that it was supposed to be y squared equals 4ax. Let's sketch that and see what it looks like. Here's your vertex. And your focus is 3, 0. That's 3 to the right. Which way does the parabola have to open if the vertex and focus are situated like that? Yeah?
Is that right?
It has to open to the right. So what that means is, if it's opening to the right, that's a positive x axis it's opening on. Positive x. Positive number with the x. That's how you'd figure out this is the equation to use. It's always a 4 or a negative 4, and this is always an x or a y. So you have 4 different options. 4 with an x, negative 4 with an x, 4 with a y, or negative 4 with a y. Those are the only 4 things. So this is positive x, opens to the right. All right, now, what is A in this case? Yeah? 3. The distance between the vertex and the focus. Well, I just graphed them. Just look at it. What's the distance? 1, 2, 3. So fill in 3 for A, and we will have found our equation. So y squared equals 12x. Now, if you wanted to type that in on a calculator, y squared is never by itself. In function mode, what letter is always by itself on the calculator? Yep.
X. Or no. Just Y.
Y. Okay, it's always y equals. It's not y squared equals. So if you want to put this in on the calculator, what would you have to do on both sides? Yep.
Take the square root of it.
Take the square root of both sides. And remember, when you take the square root, it's a positive or a negative. The only reason I did that is because you have to get used to seeing your answer written different ways. They might write the answer like this on the test. Or they might write it like what's above. It's the same thing. It's just you rearranged it a little bit. All right, now let's pick, we're supposed to get 2 more points. Can anybody think of a number that I could plug in for x that would make it easy to find y? You don't want to get imaginary numbers. You definitely don't want to plug in negatives for x. And that should make sense because the parabola doesn't even go in the negative direction. It only goes in the positive. But I'm trying to think of a nice number for x. Okay?
1.
I think that would be a little hard to figure out because then what are you going to have to calculate if you plug in 1 for x?
The square root of 12.
You have to find the square root of 12.
3.
Yeah, if you plug in 3 for x, okay, so think of it like you're making a point. Plug in 3. 12 times 3 is 36. And then what's the square root of 36? Yep.
6.
And?
Or
Negative 6. So it gives you 2 points very easily without any calculator. 3, 6. 3, 6. 3, negative 6. Good enough. There's your sketch. And we did happen to find the 2 points that lined up with the focus. So this distance right here would be the focal width. And it's 12. The focal width is actually always 4 times A. In this case, A was 3. We don't have to know that, but that's what it is. Okay, questions on our equation or the sketch? Okay, let's try another one. This time, they're giving you the equation and they want you to discuss it. Discuss means I want you to tell me 4 things. What's the vertex? What's the focus? What's the directrix? In which way does it open? Those are the 4 things you should be able to do. Now, this equation is not written in the standard way that makes A easy to see. What number are we always supposed to have on the right-hand side when you write the equation of a parabola? This one has been simplified, but let's reverse it. Put that number back. So, we're always supposed to have a 4. If you can figure out what goes in those parentheses, that's what A is. What goes inside the parentheses? Yep. 2. So there is your A value. A is 2. And remember what A is. A is the distance between the vertex and the focus. So we're going to know where to put the focus in a second. So we know A is 2. All right, so we know that A is 2. Now, for now, where is the vertex always going to be? I told you it would always be here. You'll know when it's not because the equation's going to look a little different. Yep.
0, 0.
0, 0. Now, think of which way this parabola opens. Positive number with an x. Positive x means the parabola opens which way? Yeah? It opens to the positive x direction, which is to the right. How far away is the vertex from the focus? Yeah?
2.
And what's telling you that? What's that value called?
The A value.
That's the A value. The A value is 2. So the focus is 2 units away from the vertex, and we know it's 2 units to the right. So we should write that down too. The parabola opens right. Let's say that. What would be the coordinates of the focus if it's 2 units to the right of the origin? Yeah?
2, 0.
2, 0. And now we want to write the equation of the directrix. Well, look at the sketch. Is the directrix going to be a horizontal line or a vertical line? Yep.
Vertical.
It's going to be vertical. The parabola always bends away from the directrix. How does the equation of a vertical line always start? Y equals or x equals? Which one?
X equals.
Yep, it's always x equals. And we know this distance is the same as this distance. We wrote that down. So what is the equation of my vertical line? X equals what number? Yep.
X equals -2.
-2. Focus was 2 units to the right. The directrix is always 2 units the other way, in this case left. So x equals -2. And those are the 4 things that we need to know how to describe. Okay. Questions on any of those? Here's another discuss. X squared equals -12y. Is this equation written in a way that makes A easy to see? Okay. No. What number, remember you only have a choice of 2 numbers. What number do we want right after the equal sign in this case? Yep. -4. If this side is a negative, it is not coming from A. A is the distance between 2 things. Distance can never be negative. If there's a negative on the right, it's coming from the 4, not the A. So -4, A, Y. What's A in this case? Yeah, 3. Now, read what it says on the right-hand side. -y. -y. Which way is the parabola going to open if it opens facing the -y? Yeah? Which way?
Down.
Down. So -y means it opens down. Okay, so we've got the vertex. We know that's 0, 0 until I tell you otherwise. So there's a spot for that. We know that it opens down. Here's my vertex. How many units away from the vertex is the focus? Yep. 3. That's my A value. And it's 3 units which way from the vertex? Up, down, left, or right? Yeah?
Down.
Down. It's that. 3 units down. 1, 2, 3. There's your focus. So what would be the coordinate of the focus? Sarah?
0.
0, -3. Last thing we need is the directrix. I'm not going to do a perfect sketch because we're going to do it nicer in a second. But if it opens down, how does your directrix go? Vertical or horizontal? Matt?
Horizontal.
Horizontal. And it has to be exactly the same number of units away as the focus is, but the other way. So the focus was 3 down. The directrix is 3 up. So what would be the equation of my directrix? Yeah?
Y equals 3.
Y equals 3, yeah. Yep, y equals 3. All right, now, they didn't say sketch it, but this will probably be one of the last sketches we do, so let's sketch it. In this case, what I would do is pick a number for y, and then we'll solve for x. I know we normally don't do it that way, but that's kind of how this one is set up. What would be a nice number that I could fill in for y? And then I could easily take the square root of it. Yeah?
-3.
If you let y be -3, now fill it in. -12 times -3, that's 36. And now to get x, take the square root of 36. We just did that. What's the square root of 36? Yeah?
Plus or minus 6.
Plus or minus 6. This is the same parabola we just did, but it's been rotated. It's still going to have a focal width of 12, but it's going to be a different way. So we've got 6, -3, and 6, -6, -3. Those are the 2 points we just found. And sketch your parabola. Okay. Questions on the sketch or discussing? Okay. I already told you what's in this box. We wrote that down earlier. I'm just reminding you again. Okay, so find an equation of a parabola with the focus at 0, 4. Okay, I'll write that down. There's my focus. And the directrix is y equals -4. So what they didn't tell us this time is the vertex. Well, where is the vertex in relation to the focus and directrix? Yeah?
It's in between them.
It's always right in between them. And what point is right in between those two? Tell me a little more.
0, 0.
0, 0. Yeah. This has to be the vertex, 0, 0. If we didn't know the vertex was at the origin, then you don't know for sure if you can use an equation like this. All the equations I've taught you are special for the origin. We haven't looked at what happens when it's not at the origin. It's pretty easy, but we haven't done it yet. All right, so the point is, the vertex is at the origin. We can use the equations we're used to. I'm going to start with an equals. And think about how your parabola is going to open. That's not an exact sketch. What number would come after the equal sign? We have two choices. Sarah?
4.
Yep, it's going to be a 4. What letter always comes right after the 4? Yeah?
A.
Always put the A. And now, two choices here. X or Y? Chris?
Y.
It's going to be a Y. Positive Y. That's the way the parabola opens. It opens in the positive Y, which means up. So if this is on the right, then what goes on the left? Yep.
X squared.
X squared. This is always the other letter squared. Now you get your equation. Now we can fill it in. What's A? And if you forgot, you can just read it. But what is A in this case? What's that?
4.
4. 1, 2, 3, 4. So fill in 4 for A. And what would you get for your final equation? Yep.
X squared equals 16y.
X squared equals 16y. Now, is that graphable on the calculator in that format? No. What letter are we supposed to have by itself if you want to graph it? Yep.
X or Y.
Y. You always get Y by itself. How would you get Y by itself here? Yep. Chris?
Divide by 16.
Divide by 16. So if you wrote this as the answer, that's exactly the same thing. All they did was rearrange it and put the 16 on the other side. I don't think of it this way when I'm doing the original problem. I always think of it this way first, and then if I need to move stuff around at the end, I can do that. But that's your equation. Questions on that? All right. And this will be our last one before we try an example where the parabola has been shifted. So the vertex is at the origin. The axis of symmetry is the x-axis. And it goes through the point -1/2, 2. So this is just a random point. There's no special name for it. Just a point on the parabola. Let's draw that and see what we've got. Well, first of all, if the axis of symmetry is horizontal, what way, or what two ways are you limited to the parabola opening? If the axis of symmetry goes left and right. Yep. It's either going to have to open left or right. There's your axis of symmetry. It's either going to open to the left or to the right. Now, there is one other fact we know. It contains the point -1/2, 2. So here's your vertex, and there's a point on the parabola. What way would the parabola have to open so it goes through the vertex in that point? Yeah.
You have to open to the left.
It would have to open to the left. If it opened to the right, it would never go through that point. So it has to open left. That tells us the equation we need to use. What number comes after the equal sign? 4 or -4? Yep.
-4.
-4. The parabola opens in a negative direction. You use a -4. Negative directions are left and down. So it's a -4. Put your A. And do we want X or do we want Y? Ethan?
X.
X. This is opening in the negative X direction. So we want an X. And what is going to go on the other side? This point is just basically what you haven't used. Yep. Y squared. Okay. So we need A. Well, let's think about what A is. It's the distance between the vertex and the focus. Did they give me the focus? No. Then I can't figure out the distance between the vertex and the focus. I don't know the focus. Well, A is also the distance between the vertex and the directrix. Did they give me the directrix? No. So I can't figure out A that way. What haven't I used in this equation yet? That's some of the information that's up there. Yeah?
The axis of symmetry.
Well, I know that the axis of symmetry is horizontal, so that told me that it opens either left or right. So we used that originally. But there's something else we haven't used yet. Sarah? We haven't used that point. What is that? The negative 1/2. What would that represent? Or what would the 2 represent? Yeah?
The y value?
2 is a y value. And what about the negative 1/2?
The x value?
It's an x value. So this is an x and a y value that we know is on the parabola. If you fill it into that equation, it should give you the 8th value. So we have to fill in 2 for y, fill in negative 1/2 for x, and now solve for a. 4 equals 2a, and you multiply that out. So what's a in this case? Yep, 2. Now, go back, fill this in, and write your final answer. Just like when you do like y equals mx plus b, you always leave the x and the y in the final answer. Do the same thing here. So the final answer is y squared equals negative 8x. And that's the equation. All right, so any question on a parabola at the origin? Okay, so now let's look at this. So there's a whole table you can use to figure this out. But the way I've been teaching it to you, you won't need the table. Every problem we've done so far, the vertex has been at the origin. Well, now we're going to look at a parabola that has a vertex of 0, well, maybe not 0, 0. It could be 3, 5, or 7, 9. Okay, it could be different numbers. The coordinates of the vertex, we are going to call those h, k. H is the x value of the vertex. K is the y value. H, k. And what the equation is going to look like now, I don't want to go through the whole table, but it still follows the same pattern. You're either going to have a 4 or a negative 4. You're always going to have an A. You're always going to have a single letter on one side, and you're always going to have a letter squared on the other side. But here's the difference. Instead of writing this, like 4ax on that side, now you're going to write 4a, and you're going to put a minus h. You put a minus h with all the x's now. And what that minus h does is it moves the vertex left or right. Instead of writing something like this, y squared on one side by itself, you're going to put a minus k. That minus k is going to shift the parabola up or down. So these are the 4 equations we're working with now. Positive x value opens right. Negative with an x would open left. Positive y, think about what that does. Positive y is up. Negative with a y value is down. So that part is still the same. You're literally just doing this. Everywhere you had an x in the old formula, replace it with x minus h. Everywhere you had a y, replace it with y minus k. That's the change in all the formulas. Change x's to x minus h's. Change y to y minus k's. And remember what the h and the k are. They're the coordinates of the vertex. So let's try an example with one of those. And then that'll be it. Okay. So this time, you know you have to use the fancier equation because the vertex isn't 0, 0. I mean, if you want to think of it this way, you've really been using the fancy equation all along. But the k value has been 0, and the h value has been 0. So if they're both 0, you can cross them out, and that's why I never told them to you before, because you didn't need them. But now they're not 0. Okay, let's figure out h and k first. What number on the board is h? Yep. This is h. -2. What number is k? Yep. 3. There's still one more number we have to figure out, and that's a. But we also have to figure out which one of these 4 equations are we using. To figure out which one of those 4 equations to use, what have we always been figuring out about the parabola first? Yep.
What way it opens?
What way it opens. Figure out which way it opens, and that will automatically tell you which one of these to use. Because if you get the right h and k value, and you plug them into the wrong formula, well, then it's not right. I think the easiest way to see which way it opens is graph your vertex and your focus. Vertex is left 2, up 3. Focus, up 3. Which way is the parabola going to open? Yep.
To the right.
To the right. That's the whole key to starting this problem. Okay, so we know it opens to the right. It's opening in a positive direction. What number is going to come after the equal sign? Yep.
4.
4. What letter always comes after the 4? Sarah? A. And forget that it's been shifted right now. What letter would come next since it opens to the right? Ethan?
X.
X. And what are we replacing the x with? It's not just an x anymore. Now it's x. What do you put with it? Yep.
X minus h.
You put the minus h with it. You always put a minus h with the x. Now, what letter would go on the other side? Yep.
Y.
Y. And what power would it be raised to? Second. But we don't just put a y. What do we put with the y? If it wasn't shifted, that's what you'd put. Now you put
Minus k.
minus k. Now, fill everything in. The only thing we're still missing is a, but you should be able to get a by looking at the picture. What's a?
2.
2. It's the distance between the vertex and the focus. 1, 2. Fill everything in and see what we get. Y minus 3. And you leave it just like that. You don't do any of it out. Y minus 3 squared equals What number is going to be right after the equal sign once I fill in A? 8. And now be careful here. It's x minus h. And h is minus 2. So what am I going to end up with in the parentheses? Sarah?
X plus 2.
X plus 2. It's x minus minus 2. And that's the equation of a parabola that's been shifted 2 units left, 3 units up. And it has a focus at 0, 3. Okay, any question on that? So if you look at the equations of a parabola, you'll notice every time one variable is always just to the first power, and the other variable is squared. That's what makes something a parabola. One variable is squared, one variable isn't. When you start squaring both variables, that's when you turn it into an ellipse or a hyperbola. And that's what we'll look at next time when both variables are squared. Okay. Questions on that? Okay. That and that. So if there are any questions that mention finding like lattice distance or focal width, you don't have to worry about that part of the question. Just do the other parts. What I'm also going to do is put up the test topics. Okay, so give me 1 second and I'll do that. Right, so there are the different topics that are on the test. Test covers 9.1, 9.2, and the first part of 9.4. So these 3 are what we did today, all about parabolas. Graphing in parametric and graphing in polar. We did those on earlier in the week. Plotting points in polar, that was on, I want to say Tuesday. Eliminating the parameter, that's when you get rid of the t-value in the equation. You solve the first equation, you solve the x equation for t and then substitute. And then converting between polar and rectangular, I think that was on Tuesday as well. All right, so those are the different topics that are on the test.